Hello, today we will start the next part of the content, that is physical ergonomics principles and issues. So, under these physical ergonomics principles and issues, we will mainly cover anthropometry, biomechanics related to the posture, awkward posture, problems related to that, and how we can intervene the design to take care the physical compatibility of the user with the product. So, next what is physical ergonomics? Let us take few examples from our daily life. If we go one by one, so this is very common picture, every one of us have gone through this exam hall and studying in the classroom. So, first thing, after sitting a bit long time, you will feel problem in your body and you will feel a bit awkward, and you need to change your posture a bit to release those things, and then you are feeling bit comfortable. So, there is a point that the furniture is bit comfortable to the user. So, this is very much related to the physical compatibility of the person with the furniture. Next picture is to open the can. We use usually this type of can opener, that product. So, we need certain force to use that. We will elaborate this problem later on. So, that is also fitment should be there with the hand dimension and the interface what we are using to open that can. Next is a very common example in control panel, or where we have certain switches like car dashboard or something like this. All these products we are seeing. So, in this case it is very obvious that first thing, that switch is enough big that this finger is compatible to the switch dimension. Next is, it is very important that once you are manipulating one switch, it should not interfere with the other switch of the control. So, it is very important to keep distance in between these two control. So, from the point of view of fitness with the control panel and the user hand dimension, it is very important. Next is, whenever we are traveling in a train, we have seen this type of thing and product, and usually we have seen that is pedal operated. The person is, the brake is through this leg operated pedal, and the person, once he wants to stop it, he is operating that brake with his limb. So, in this case it is very important to see that at what level, at what height, if the paddle will be there, so it will be very comfortable for the person to use it, to put certain force so that he can manipulate it very easily and comfortably, because he has to do simultaneously two activities. One is, it is going, it is moving from one place to another place, and again he is breaking it, and simultaneously he is serving this thing. So, to take care all these activities, it is very important to have a physical fit of the person, so that the person can do it very comfortably and easily without any error. Next is, we have seen and we are traveling in this type of autos every day. So, where we are seeing that driver is sitting here and he should be able to see all the roads, so that there won't be any mishap it is happening. So, in this case, this part is very important, and at which height this will be there, so that the driver can easily see without any barrier. And next is the physical fitness. Whenever we are going to have some dress, the first thing is the fitness of the dress with our body dimension. So, this is very important, all these in these 6 pictures what we have discussed just now. So, this is the overview, why we need physical fitness, why it is important, body dimension, why it is important. Also the force they need, and what is the visual clearance they want, and the posture and the strength of the person here. So, in all these cases we are taking care few physical aspects of the user to make it compatible with the product. So, mainly the issues we will cover in this case is the fit. Here it is fit with the person. In all these cases fit is very important and you can't neglect it anyway. Comfort, which is once it is correctly fitted with the person, it will be comfortable. Space, height, reach. Reach, in this case the paddle should be easily reached by this user when he is doing this activity, moving towards, and simultaneously he is serving this thing. Reach, then strength, you need certain strength, in this case strength. Visibility, in this case it is visibility. So, all these issues are discussing under physical ergonomics, and mainly we will first discuss anthropometry. So, what is anthropometry? Anthropometry is the subject which deals with the measurement of the human external body dimension. So, external body dimensions, it can be hand, limb, each and every body parts in included. So, it includes the measurement of body parts, their strength, range of motion. We will discuss this in the later on in the presentation. So, anthropometry has come from two Greek words, that is anthropos, that means human, and metrikos means measurement. So, measurement of human external body dimension is anthropometry. So, if we consider when we are sitting or doing something, either we are static or we are in dynamic condition. If we consider this case, it is mostly a static condition, or here if we see he is in the dynamic condition, this is in motion. So, anthropometry, there are two types, that is static anthropometry which is structural, and dynamic, that is functional. So, now what is static anthropometry? Here we have seen, we have two figures here, one is erect and another is sitting. So, mainly external human body dimensional measurement taken when a person is placed in a rigid or static position, then we are taking static anthropometry. It is mainly height of the person, this is the height of the person, this one. Next is length, breadth and depth. So, breadth is, this is breadth, so this is breadth. Length can be from here to here, to then from shoulder to this knuckle, that can be the length of this hand, and depth is this way. So, once if this person is standing against a wall, so this is the depth of the body. So, mainly we are considering this height, length, breadth and depth. So, how it is relevant, how it is important, and why it is important to consider the anthropometry. Let us take two examples. This is a chair what we are sitting in a classroom when we are studying. So, if we consider the person when he is sitting here, so it is mainly like this, and then we need this dimension to understand what will be this height. Another thing, we need this breadth to design this breadth. So, in this type of cases, we need the static anthropometry. When the design is actually, when the person is in static condition, you need that type of product. Next, another example can be the car seat. When you are in the driving position or when you are sitting in the car, mostly your body is static. In these cases, if the driver is here, top of the car wall is here, so then if the person is sitting here, you need certain clearance on the top of the head. So, in these cases, it is very important to measure what is the height when the person is sitting on a seat, and then you can consider what should be the clearance. So, in this case you need this height. So, these are the few examples of static anthropometry and how we can relate the static anthropometric dimension in design. Next, going to the second type of anthropometry, that is dynamic anthropometry. Dynamic anthropometry is mainly functional dimension. Mostly we are always in motion. hardly we are sitting static. Though we are sitting in this chair also, we are not static. We are moving, maybe we are moving our hands, we are changing our legs like this. So, we have to understand what is the dimension when this person is moving or in dynamic condition. So, mainly dynamic anthropometry deals with the measurement of the human body when it is in movement. For example, when you have something in your shelf, in cupboard, so you extend your hand to reach that and to grab that product. In this type of cases, the example is reach and the angular range of the various joints that we are measuring in dynamic anthropometry. For example, if the person is standing, so then you want to reach something, then you extend your hand. So, that is not in a static condition. So, then and if you want to take something from an above shelf or below, then you need to put your hand like this, then you can move it this way or this way. So, that is the angular range, how you can move your hand along this angular range of this. In case of dynamic anthropometry, we measure when in this condition, when this is completely horizontal to the floor, when what is the distance the person can cover or what is the reach the person has, and when he is in this condition, as our body is curvilinear, that means it is not like this. Once you move in this condition, it is something angular. So, it is not like this, but it is like this. So, when you are moving your hand in this direction, your reach is getting decreased. It is not that much, it is getting decreased. Or in other way, if you putting your hands down, then same thing is happening, your reach is getting decreased. So, in this condition, you need dynamic anthropometry. Another issue is if you have to do some activity in front of your whole wall, maybe you have some control design or something to manipulate in machine or something bigger product, then you need to use the whole dimension. Maybe from here you need to change something here, then you are moving. So, this is the range of motion what the person can use to manipulate something. So, all these functional dimensions are under the dynamic anthropometry. So, now take few examples. This is one example from air company, and this is the boarding region where the person is sitting and they are issuing us boarding pass and taking the luggage in the conveyor belt and giving the tag. So, if we see here, when the person is sitting, he or she is doing so many activities simultaneously. So, first he or she will take care of your pass or ticket, and then he will match, or he or she will match that, and she will give you the tag or something, and she will check the weight, and then he or she will keep your luggage here and tag it. So, in this condition, the body is in full dynamic condition. In this case, you have to take care, when the person is in static condition, what is the dimension? Again, when he is extending to get your boarding pass, what is the dimension? Again, when he or she is putting this luggage or something, or checking the monitor to check your weight of the luggage, then what she or he is adapting the posture. In this case, dynamic anthropometry is very much important. So, when you are designing something, workstation or this type of modular furniture design, you should take care the dynamic anthropometry of the person, what can be the limit and abilities of the person. Next example is the cupboard. So, when the person is standing, so if the person has this height, so then so if the person, whether the person can reach this very well or he has to reach this thing, and whether if he is standing here, then whether he can get this product. So, in these cases also you need to understand the dynamic anthropometric dimension of the user. So, when you are doing this type of design, it is very important also to know what should be the depth of the cupboard. So, if you extend the hand, it should reach the extreme point of the cupboard, so that if you keep some product here, it should be easily accessible by the user. So, dynamic anthropometry and in this case reach is very important to consider to finalize the depth of the cupboard. So, these are two examples. So, now what is the principles of applied anthropometry? When we are measuring the dimension is fine. So, after that we need to apply in design, because if we see every one of us are not in a similar or identical height. So, if we see somebody is very fat, somebody is very thin. So, when we are making some design like Caesar, when we are taking this type of product, when it is a universal product. So, it is not customized for a range of people. So, it is for a range of people who can be a kids, who can be a adult person, who also can be a feeble and weak elderly. So, in these type of cases, or you can't, in this type of cases you have to have some dimension what can fit to a range of people, not a very particular section of people like only adult, only kids, only elderly, like this. So, the principles of anthropometry is like this. So, just take an example. So, here we have plotted, assume 100 people you have. So, we have plotted the 100 people's height in this axis, and how many people have this that type of height, frequency of the person for a particular height in y axis. So, once we have plot this data, we got this normal distribution curve. So, now if we consider this normal distribution curve, so we have 100 data is present under this. When you are designing Caesar or a can opener, for whom you will design that, for whose dimension you will take. Maybe mostly we are telling that it is for average, but if you see, if we are, this average is here as it is a normal distribution curve, this is the mean. So, your average is here, but if you design it for the average population, then hardly you will cover this part of the population. If you see, we are not considering this range of population and this range of population. So, in this case, that product won't be compatible to this section and this section also. That is why when we are making any design, and we are considering the principles of applied anthropometry, we are usually not considering the average. We are considering the 5th percentile or 95th percentile. What is 5th percentile and 95th percentile? When we are approaching from 50th percent or the average, as it is a normal distribution curve, we have 50% data here and 50% data this side. It is more than the average and it is less than the average. So, if we consider this 5th percentile of the 5th percentile and here the 95th percentile, then we will cover this whole section. This whole section we will cover if we take this data and this data instead of only average. Okay. So, when we are taking this and this, actually this is called 5th percentile and this is called 95th percentile. So, actually 5th percentile, what does it mean? Actually 5% of the user population you are excluding. So, 5% of the user population have height dimension below this height. So, the percentage of people within the population having body dimension lower than the specified value. This is very important, that lower than the specified value. So, when we are taking 5th percentile value, then 5% of the user population is lower than this value. When we are considering 95th percentile, then 95% of the population have height lower than this 95th percentile value. So, this is the importance of taking percentile instead of average. Now, we will see two examples how we can use. So, when we will consider 5th percentile and when we will take 95th percentile. So, take few examples. So, when we are designing a door, maybe you are designing a door and all of you know the height of the door, how to decide. So, if we consider the average person, maybe who is very tall, he or she will be unable to cross the door very easily. He or she will have hindrance. So, now what value to consider? Then you have to consider 95th percentile value. So, if you take 95th percentile value of the height dimension, then 95% of the population can go through the door very easily. So, minimum dimension of the door should be 95th percentile of the height. So, for minimum dimension, a percentile value of an appropriate anthropometric dimension is chosen. For in this case of doorway design, it can be the stature height of the person. So, that is the anthropometric dimension we have chosen. This is the dimension we have chosen and this is the percentile we have chosen. So, to determine the height of a doorway, first we have to finalize what is the dimension, that is in this case stature, and what is the percentile, that in this case it is 95th percentile. So, like this we can use this in case of design. Now, coming to the next point, when in this case we have used high percentile for a minimum dimension. So, the doorway should have a minimum dimension of this 95th percentile. Now, going to the next one, that is maximum dimension. For example, you have a door and you want to make a handle of the door, so that the person who is very small height, he or she also can able to operate that thing. In this case, what you have to do? You have to take that 5th percentile data, so that you will only, if you go to this graph, if you take 5th percentile of the data, you are only excluding this part and you are taking care the whole rest of the graph. So, if you are taking 5th percentile of the data, if person has a height below than this, that part you are excluding. That means you are the smallest section, less than 5% you are excluding. Rest of the people will be able to manipulate. So, a low percentile value of an appropriate anthropometric dimension is chosen to determine the maximum height of a door latch. Here, that is the door latch, so that the smallest person in a population will be able to reach it. So, these are the two applications how you can apply the percentile. Now, here are few more examples. It is not as simple as this, like this, that just only the door height you have to decide, or just to decide your door latch. So, if we take this product, like this is a chair, you have so many dimensions. If when the person is sitting, so the person is sitting like this, his legs are here, and so in this case also the person has certain breadth, he is sitting this part. So, in this case dimension will be so many dimensions you have to consider to design. For example, the hip breadth of the person need to consider when you are designing this seat breadth, so that the person will be able to sit here. Another thing in the sitting height, so because from the knee the legs will be dangle here, so you have to take also the from knee to floor, that is called popliteal height. So, that popliteal height also you have to consider, so that person can rest their feet in the ground when the person is sitting in the on the chair. So, in this case, when we are deciding this seat breadth, you have to consider 95th percentile value of the hip breadth data. So, hip breadth is the dimension you are taking, and 95th percentile if you are taking, that means 95% of the population will be able to sit here. But in this case, if you take 95th percentile of the popliteal height, then for smaller person it will be happen like this, their legs will be up to this height. So, this, as they have a shorter height, they can't reach, so their legs will dangle. So, in this case, for this dimension, for this popliteal height, for this height dimension, you can't consider 95th percentile. In this case, you have to go with the shorter person. So, in this case, you have to think of the 5th percentile value of the popliteal height dimension. So, in this product, for seat breadth you have to take 95th percentile, for seat height you have to take 5th percentile of the popliteal height data. So, similar thing if you think of this bench. So, in this type of complex dimension, if you make it for shorter person, taller person will have difficulty to have food in this desk. So, they will have some angular posture will be there for very taller or shorter person, or shorter person can't reach this height. So, in this type of complex design, we should understand the table height, the seat height, and also the sitting height of the person. So, these three dimension need to be considered when we are deciding something like this dimension, which is far more complex. In this type of cases also, it is important to take care this reach distance. Obviously, it should be from the point of view of shorter person, because if the shorter person can reach this steering wheel, then obviously a taller person can reach. So, you can take this 5th percentile dimension of this data, but in case of this sitting height thing, you have to think of the 95th percentile of the height data, because if you can accommodate the taller person, obviously the shorter person can use. So, this is the implication of percentile in your product design. But for few things, as design is very context specific, if it is something emergency switch or something like this, we have to take care that for 99th percentile, so that 99% of the population should use that thing very easily. If the person is in wheelchair, because it is an emergency switch, in emergency switch you can't reject any dimension. So, it should be like this, that 99% of the population should use that. If the person is also wheelchair bound, he or she should have that opportunity to use that. So, it depends on the context of the design what you are doing. What are the issues we need to take care when you are doing this anthropometry thing? One is personal space. Personal space, when we are sitting, we have a personal territory. We are not seeing just side by side. We have certain space in between two persons. That is the personal space. Hidden dimension, for example, when you have a table of 6 person, 2 person, 2 person, 1 1, then when we are sitting, we have in between some space. So, we have certain space like this is called hidden dimension. So, when we are designing some table or something, we only can't consider the hip breadth of the person and 2 persons of the hip breadth. We should consider the personal space and hidden dimension, and all this personal space, hidden dimension is very much dependent on the culture and the persons who are sitting and the characteristic of the person. All these things need to be considered when you are designing this thing. Next is people is in motion. When we are designing something exit door or something like this, maybe a auditorium or multiplex, then we should take care how many persons can simultaneously go, and whenever the person is in motion, so how much space they need. So, whenever the person is in motion, it is definitely more than the static condition they will. So, that is called we have to take care the when the person is in motion, that dimension also we should consider. Another is range of joint motion. We have considered that for the case of shelf and all those things, how much for shelf, it can be for any control panel with what is there. So, how much joint range of joint motion you have. If the person is standing here, so if the person is standing here, so if he is extending, so what is the range of motion he can have. So, that is another important. Another is elderly and physically handicapped. So, if we consider this picture, so if we see here, this is the physically able person and this is the wheelchair bound person. So, in one home, if you are designing some shelf or something, what you want to be used by both the person. So, then we have to think that what is the common reaching zone of the wheelchair bound person, also the able bodied person. In this case, though the physically able person have a range of joint motion and reach area this much, but in this case, as the person is wheelchair bound, this person have a reaching zone like this limited. In this case, we need to find out what is the common reaching zone. So, this can be the maximum common reaching zone and that can be the comfortable common reaching zone. So, if you want to put something which is each and every time you are accessing, very frequently you are accessing, that we should put in the common reaching zone, and next to that, second priority, less accessible thing can be put in the maximum common reaching zone. By that thing you can optimize this design for both this person able bodied and the wheelchair bound. So, next is what are the factors which affect the body dimension. One is age, sex, race. So, ethnically we are very different from one population to another population. Anthropometric dimension is getting changed, and body build and occupation. If the person is very physically active, then the body build will be different. Also, these body build and is also very much dependent on the diet of the person, health, and whether the person is doing exercise or physically fit. So, these are the few important factors which we need to consider when we are applying this anthropometry in product design. And when there are mainly three issues, that is the for whom you are designing, it is the designing for extreme individuals. So, when you are designing for maybe door height, door latch, then you should take care all the persons, extreme individuals also you should take care. Next is design for adjustment. Designing for adjustment where you can give the range of adjustment in your furniture. Maybe you are giving a chair design, change the height of the seat, then you can give adjustment from 5th to 95th percentile, so that you can make it accessible for 90% of the population, but simultaneously you are giving the adjustment. So, according to my height and height and comfort, I can change. So, but always it is not possible to give the adjustment, it depends on the context and the product you are designing. Next is designing for average. Designing for average, the whole product usually never be a designing for average, but few dimension can be designing for average in a product. Not all the dimension will be for average people. For few definitely few dimension will be for 5th or 95th percentile. Rest 1, 2 or 3 dimension can be for designing for average in any product. Thank you.